Hello, I'm Brian Canfield, and today we're going to further unravel the mysteries of glass. And in particular, we're going to discuss how to make antique mouth-blown glass, the Rolls Royce of glass. In addition, this is the style and process that is used historically even 1,000 years ago. And today with us to talk about this process is Gary Cohen. Gary, how long have you been in the glass department, and what's a little bit of your background?
I've been a professional artist for well over 30 years. I have several different disciplines. They are clay, metal, and for the last 25 to 30 years I've been specializing in glass, primarily glass blowing. I've been instructing out here at Palomar College for about 28 years now. And I've been running the glass program for the last, say, 15 to 18 years.
Speaking of the glass program, how unique is it to have both stained glass and glass blowing at a college level like this? How unique is that?
It's extremely unique in the sense that what connotates university status in a college is the diversification of the elements within an individual program. And for a small community college such as Palomar College, like this one, to have stained glass, fusing, and hot glass in one particular area is unheard of.
It is quite rare. I love this program. So when we get into glass blowing, what is glass made of, and where does it start, and how do you start the process of blowing glass?
Well, first of all, you have to have certain kind of equipment that will go to a hot enough temperature to actually melt the glass. The glass itself is usually composed of primarily silica sand, and then we add fluxes to it to lower the melting point so that we can burn it in our furnaces here.
Right. So let's talk about heat real quick. What temperature are you working the glass? How hot is it when it comes out of the furnace, and how hot do you need to maintain it to manipulate it?
The glass always works best when it's extremely hot. Our blowing temperature that we maintain here at Palomar, at our furnaces that you see in the background, are usually held somewhere between 21 and 2200 degrees.
Fahrenheit.
Fahrenheit. Now, the ideal blowing temperature that I particularly like is around 21 to 2150.
Okay.
How I gauge that is as I gather the glass, if it drips off real readily into the tank, then that's pretty much hot enough.
Okay. And what about color? What actually gives the color to the glass?
Well, all colors in glass, and including glazes in ceramics, is metallic oxides. And I'm sure you're familiar with some of them. More common ones are cobalt carbonate, iron, there's vanadium, a bunch of the metallic oxides.
You know, and one of the myths out there, which is a true myth, is that gold gives us what color sometimes?
Gold gives us what we call a ruby or a pink, and we're very, very, very covetous of that particular color. Not only is it expensive to own and buy as an ingredient to blow with, but the price of gold these days makes it almost prohibitive to make.
Right, very expensive as well. So some of this mouth-blown glass, in the United States, it's pretty rare nowadays to actually have a manufacturer make this. So most of what we find today available to artists internationally come out of pretty much Europe, mostly Germany, Poland, also France. They have had a long tradition of making mouth-blown antique glass. And if you think back historically in some of the original windows, we have these small diameter 4 to 5 inch circles we call rondelles. And today we're going to actually show how to make a rondelle. So this rondelle process, talk us through how to make a rondelle, Gary.
Absolutely. The rondelles, since they were being used as a window type treatment early on, they have to be a certain thickness. In other words, if the glass is too thick, it loses its optic quality and distorts the vision as you're looking through the glass.
And so also it has to fit in the channel on the perimeter of the lead.
So that means that the diameter or the thickness as far as either in millimeters or in inches, is 1/8 of an inch thick, maybe 3 to 4 millimeters in thickness. We start with a little gather of glass on a hollow blowpipe. It's blown out to a certain thickness of bubble, and then we did two methods today. The first method I want to talk about is where you actually take a flame and you heat the end of the bubble and continue to add a little pressure to the bubble, and as that molten spot heats up, it pierces the bubble. And then we do a move called a necking move, whereby you squeeze the glass at the blowpipe end of it way down to where it's just seals the bubble off. At that point, we can kind of trim off the excess. The end is then heated up to an extreme heat and spun using centrifugal force until it goes completely flat. The other method is where you take an external rod called a punty rod, open up, touch it to the bottom of the bubble, and then open it from the blowpipe side and spin it out till it goes flat. Either way, the heat has to be extreme enough to make the glass loose and molten enough for centrifugal force to flatten the glass out as you spin.
So you've made the rondelles, you've spun them out. Then once they're ready on the pipe, what is the next process?
The next process is simply sizzled, broken off, and heated in as it lays flat to do away with the scarred mark where it breaks off the pipe.
So you've taken it off the pipe, then you put it into the leer. What is that about?
A leer is another name for an annealing oven or a holding kiln. Those three words are synonymous. What it does there is we know from our experience of using this glass that the annealing temperature is around 900 degrees. So we have our oven set at 900 degrees. And what that does is it relieves all the stress within the glass from the heating and cooling and blowing process, and relaxes the glass enough to make it safe and stabilize the glass. The temperature is then dropped slowly over several hours to room temperature, and then the glass has been annealed.
Okay, so that was for the rondelle, and it's similar for the cylinder glass, and that cylinder can be made into what we call sheet glass. Talk about the process of making the cylinder glass.
Everything in glass is started essentially the same way. You start with a bubble, take a series of gathers until you have arrived at a quantity of glass to give you the desired amount. So today we were making 18-inch cylinders that were, say, 6 to 8 inches in diameter. And that meant that we had to start with our raw materials with a ball of glass about a small soccer ball size. All right.
And how heavy is that? What do you gauge that at?
Glass is about 8 pounds a gallon of glass, which is a little container about like this. So that's not the issue. The issue is the fact that it's on the end of a 5-foot pole. So a ball of glass that might weigh somewhere between 10 and 12 pounds at the end of your 5-foot pole could be somewhere around 20 pounds.
Considerably heavier, right?
Considerably heavier.
So then you do your gather, and then what? How do you get that long cylindrical shape?
Well, how I do it is I first start by blowing a round bubble, and that is going to be wider than the diameter of the cylinder that I'm going to try to finish. Then I heat it up to where it's fairly loose, and what I mean by loose, it's actually moving at the pipe. Then I let gravity sort of elongate the bubble to where it gets almost the diameter that I need it for the cylinder. And then what I do is I take a series of rolls over a table like this called a Marver table and establish the diameter of the cylinder. Once the top part of the cylinder is established, I can continue to blow wider and swing down and Marver to that diameter. So it's puff, establish your diameter, puff wide, swing down, establish the diameter, puff wide, swing down, establish the diameter. That's essentially
quite a long process. How is it then that you open up the end of the bubble to create that opening for the cylinder?
There's a couple of methods that we use today. One method is to simply take a hand torch and superheat a tiny spot right at the end of the bubble, and then continue to apply pressure to the bubble. As the piece heats up, it gets thinner and thinner and thinner and eventually pops through.
So when you say apply pressure, what are you doing?
You're mouth blowing it
Okay.
at that point.
Okay.
Okay. The second method, which is also a common method, is to take an extremely heated, fresh gather of glass and touch it to the thin end of the bubble, and then apply pressure to that, and then you puff it through and trim it off clean.
So you have your cylinder shaped, and then you go through the same process of putting it into the annealing,
Absolutely.
just like the rondelle.
Yeah, except for the rondelles are so thin, they dissipate the heat a little more evenly. So before we decide to put away the cylinder, we have to go through what we call a series of reheats, which actually balances out the temperature throughout the glass,
Right.
so that there's no shock when you put it away in a cooler layer.
So the bigger the project, the thicker, the longer it takes
Correct.
to anneal, and also the more heat you have to keep it consistent.
Correct.
Okay. So once then it's annealed and cooled off, then you have two open ends on the cylinder.
Correct.
And then you're going to take and score out, generally it's about an inch strip. So then there's two ways once you have it annealed to make it into sheet glass. Once you take out that strip in the cylinder, you either put it back into a kiln to heat it up enough to where it'll flatten out due to gravity, or another way, if you have a bigger leer, you can actually keep it inside of there and take something that kind of looks like a, almost like a hoe that you would use farming, and you use that to flatten out the glass as well. And once you have that flat glass, then we can take it and apply it to a lot of the different techniques that I've gone over in the previous segments of this series. Well, Gary, I really appreciate you opening up the studio and showing us some of these different techniques. A lot of these different techniques, again, have been around for hundreds and hundreds of years. And the reason that we still do them today is because we've carried on the craftsmanship and the artistry of these techniques. And I think they're tried and true. So I hope that I'll see you again and you continue to make stained glass. Thank you.